Welcome to EDU World Space.
Let's use the formula for exponential growth. We have some final amount given some initial amount times 1 plus the rate to some time. So if it was 200 after 15 minutes and 1900 after 30 minutes, we could say that the final amount here to find the rate was 1900 given an initial amount of 200, and 15 minutes had half, so t would be in minutes here, because going from 15 to 30 minutes, it took 15 minutes to get to that level. Divide both sides by 200. 1900 divided by 200 is 9.5. Then we'll take the 15th root of both sides and then subtract 1. So it's the 15th root of 9.5 minus 1. You can find the 15th root with decimals under functions. On a handheld calculator, you should find the nth root as well. The 15th root of 9.5 minus 1 is 0.1619. So let's see, what is the initial population? Well, we don't know yet, do we? We can say what we know so far is that we've got our rate here. So the first question is, what is the initial population? Well, we can first find the doubling time if, well, we can use this actually and take the 200 after 15 minutes. So we know that there was 200. We want to find what is the initial time after it took 15 minutes to get to 200. So you would divide 200 by 1.1619 to the 15th, and 200 divided by 1.1619 to the 15th is, we'll say 21, because that's a population. So the initial population should have been 21. To find the doubling period in minutes, now our formula looks like an initial population of 21 with a rate of 1.1619. We want to know how long does it take to double, so we can even just call that 42 because I've doubled the initial population of 21. So when we divide by 21, we get the 2. Now we'll take the logarithm to both sides. I'll pick the natural log. That way we can apply the power rule and we can bring the exponent out front. It'd be t times the natural log of 1.1619. And so divide both sides by the natural log of 1.1619. And you'll have the time. So the natural log of 2 over the natural log of 1.1619. We're rounding time to 2 decimal places. So this would be 4.62 minutes to double. Next question, find the population after 60 minutes. Well, our initial population is 21. We want to find after 60 minutes what the population is. So that would be 21 times 1.1619 to the 60th power. And that would be 170,000 to the nearest whole would be 744. 170,744. When will the population reach 11,000? That would be an A value. We're going to solve for t. So divide both sides by 21. Then we'll take the natural log of both sides. Use the power rule to bring the exponent out front. And then divide by the natural log of 1.1619. And we'll have our amount of time. So the natural log of 11,000 over 21 over the natural log of 1.1619. And that would be about 41.73 minutes. Check that one more time. 41.73 minutes to 2 decimal places. We should be all set now.